997, 998, 999. Oh, 1,000. Whew. Oh, sorry. Didn't know you were there. Just finishing up my 10th set of 1,000 curls, microscope curls. There's a lot of purposes for microscopes. Looking at things that are really small is one of them. Getting a little pump in, that's another. Anyway, it's appropriate because guess what? We're learning about the muscular system, something that I obviously know quite a bit about. Or maybe not that obvious. I honestly do need to take a couple more trips to the weight room. But you might think of muscles as the things that help you move. And that's the best way to think about it. Works with the skeletal system for movement, but it does go beyond that even. And there are a ton of purposes. You can see a lot of them on this slide. We see the people dancing. It's a former profession of mine. Not really. I'm pretty decent at wedding dances, but not much beyond that. I'll show you moves sometimes. Playing sports like volleyball and other things is another obvious use of muscles, but even when you play video games or eat, use a knife or fork or chopsticks, you are using muscles to move your bones to do things. It does go beyond that. The muscular system also helps your food move. So the food that you eat travels through the digestive system using muscles. We'll learn more about the digestive system later in this class, but for now, you should know that the muscular system has a really big role in peristalsis, which is how that food moves. You can see on this diagram the direction of food traveling in a certain direction because certain muscles are contracting in your digestive system without your knowledge of this even happening. I also have a picture of the heart. Your heart is a muscle. Its contractions lead to the movement of blood throughout your circulatory system, throughout your whole body, so that the blood can carry the necessary nutrients and oxygen that every cell in your body needs. So yeah, the heart and even the blood vessels, the arteries, the veins, the blood vessels also use muscles to move blood around. Okay, so it's not just moving our bodies, it's moving things within our bodies too. Alright, there's 3 different types of muscle tissues that I want you to know about. The 3 major types the 3 types of muscle tissue are cardiac, smooth, and skeletal. Alright, the first that we're going to start with, the first type of muscle tissue is cardiac muscle tissue. Cardiac, anytime you see that word, I want you to think it's referring to the heart. Okay, cardiac muscle tissue is only found in the heart. Yeah, again, anytime you see the word cardiac, you should think heart. That type of muscle tissue is a little bit different than smooth and a little bit different than skeletal. It's kind of like both, but also dissimilar as well. So it's an involuntary type of contraction. You don't tell your heart when to beat. It's something that happens without you knowing. So when I say it happens without you knowing, that's another word for that is involuntary. It's not a thing you're consciously making a decision to do. Cardiac muscle tissue is also striated. You can kind of see that if you can look closely at the muscle tissue pictured here. But there are striations. I think of when you eat like a chicken breast or something like that and you tear apart that piece of meat from the chicken, you can kind of see striations. Now skeletal muscle is striated, but so is cardiac. So those striations, those long muscle fibers is what you're looking at really. That is a characteristic of cardiac muscle tissue. And again, it's only found in the heart. So that's one type of muscle tissue that you should know about. Another is the smooth muscle tissue. Again, This type of muscle tissue is also involuntary. You don't tell it when to contract and when to relax it. Involuntary or smooth muscle tissue is found in your digestive system. You can think of your esophagus pushing food down, whether you're hanging upside down or right side up. Through the contraction of smooth muscle tissue, you can move that food to where it needs to go next, the stomach. And that happens throughout the digestive system. It also happens in your blood vessels. So there are smooth muscle tissues found in your blood vessels, also to contract and expand your lungs. There's also smooth muscle tissue there. This is not striated muscle, so it looks a little bit differently under the microscope than the other two as well. The last type of muscle tissue I want you to know about is the one that you probably think of the most when you think of muscle. That's skeletal muscle. It's called skeletal muscle because it moves your skeleton. It moves bones. This is the type of muscle that is a voluntary contraction. You tell your muscle when to contract. It doesn't involve a lot of thought. You can move just about anywhere, and you are contracting muscles to make that movement happen. That kind of muscle is skeletal muscle. So this is a voluntary thing. It is striated. The chicken breast that I had talked about earlier, you can tell that there's striations there, but there are dense muscle fibers that contract or shorten to make bones move with skeletal muscle tissue. One thing I want you to notice before we go on to the next slide is how many nuclei, that's plural for nucleus, there are in any one of these muscle fibers or muscle cells. There's a ton of them. It's multinucleate, it's called. And there's so many nuclei there for a reason. Think about what muscles need. And think about what you need in your diet if you want to build muscle. You need a ton of protein. Now, to make a lot of protein in your muscles that is necessary for it to contract and then relax, you need a lot of nuclei with the instructions to make that contraction happen and to make protein. Okay, so the reason you see so many nuclei in any one cell is because you need those nuclei to make protein. Skeletal muscles work in pairs to move a bone. What I want you to remember about this, muscles can contract, but they can't extend. They can contract and relax. So think about how your triceps work, since that's in your biceps. They work together to either bend your arm by contracting your biceps. So this muscle on this side of your humerus bone, it shortens, it contracts, pulling the rest of your arm closer. To extend it, your biceps doesn't extend, it just relaxes while your tricep flexes or contracts to shorten there. So your bone moves, your arm moves the other way. So this is a decent picture that you can see that happening. But anytime you have a hinge joint like that, maybe it's your leg, maybe your hamstring and your quadricep are moving bone the same way. They work in pairs. One contracts, and then the other contracts to move it the other way. So it's just contracting and relaxing. That's all muscles can do. They can't extend. All right, last thing I want to show you is the structure of muscle. Here you can see a picture of kind of a cross-section of what a complete muscle would look like. You can see the bone there. You can see the tendon that attaches the muscle to the bone. That's a term that we've seen before in the skeletal system unit. And then we have the muscle itself. I want you to think of the structure of a muscle kind of like you think of a thick rope. You can see some pictures to the right here where if you unravel a rope at all, you'll notice that it's made up of like smaller ropes that are twisted together. And you'll notice if you unravel that smaller rope, it's made up of finer filaments and finer pieces of string that make that rope so strong. Well, muscles are strong too, and they really do kind of look like a large rope that's been unraveled. You can see the different segments of these muscle fibers, and then eventually smaller pieces of that muscle, and then finally you get to the cell level, and the muscle fiber is actually a muscle cell with, again, so many nuclei that that help make proteins so that the muscle can contract and then relax. Okay, so that's the structure of muscle. And that is it for this video. Good luck with everything else in this unit. See you next time. Next time I'll be much bigger because I've lifted weights actually, and yeah, you're gonna tell the difference. I can tell. It's gonna be beastie.